Hello everyone. So we are gonna have another AIME problem today. So this was a number 15, which is the last problem meant to be really challenging. So since we're gonna use a lot of algebra and geometry, so be ready for that. And also I'm gonna add some background info about some of the stuff we are gonna use in this solution. So if you don't really know some of them, so go ahead and take a look at those before you really dive into this problem. So we have a triangle, three sides are given, and 2 points given on AC, and we are given those 2 points dividing the sides into two equal pieces, and then there are some equal angles going on. So it's not really obvious how we start. So let's go ahead and try um, drawing something to visually see what's going on. So I'll say this is A, this is B, and this is C, right? So the point M lie on AC. So this is AC such that AM is the same as MC. So which means M is the midpoint. Okay, and since we know the AC was 13, so that should be 6.5, and this is 6.5. Okay, and D lies, okay, D also lies on AC such that ABD, and DCB, okay, there is another point on this segment that's gonna be D, and when you connect D with B, so you will get angle bisector. So, but we don't really know if this is gonna be to the above this M or below this M. So which we are gonna use the other information we are given. So AB is 15, and then BC is 14. So if you remember the angle bisector theorem, so when you have the, let's say this is gonna be drawing something like this, and the ratio of 15 to 14 has to be the ratio of those pieces as well. So which means if this is 15 and 14, then this portion of the part of the AC, when you take the angle bisector, should be larger than the other portion, which is why the D has to be actually lower than the point M. So let's assume this is somewhere right there as our D. So again, if you really don't get this part, so you really want to review the angle bisector theorem. So that's basically what's going on. And okay, so we have this, but we don't really know each part of this, but we may find if we need to. So the second part now is we have N and E such that AB on AB such that AN and NB is the same. So which has the same approach, I guess. So that should be right in the middle. So that's gonna be 7.5 and 7.5, right? And ACE, so there will be E, same as ECB. So it's the same idea. So when you draw a angle bisector, so let's have our median first. So when you have angle bisector, since this is 13, this is 14, this is larger than this one. So this part of the angle bisector should be larger than this one. And only way that will happen, our E has to be above that point N. So that will be somewhere right here. So let's say this is E, and we have now another. But now the question is already challenging, right? And what we are told after that there is a point P other than A. So this is A, other than A, intersection of the circles of A, M, N. So A, M and N. So if you try to draw a circle, so it will be something like this. And you can try better than what I did right now, but I will just kind of visually see how that looks like. And ADE, so ADE, so D is right here, E is right here, D is right here. So it looks like we're gonna have smaller arc right here, and we are gonna have something like this. But the problem with this, right, when you when you draw this, let's just say this circle and this circle intersect somewhere right here based on my drawing, which is really messy, which we don't really know where this is gonna be touching because of the other two angle bisector and medians. So which looks a bit bad. So in some cases, if you don't really need to draw everything, you just actually ignore them, which I will do as well. And this is how you actually can start with at least. As soon as I see this one, I can just kind of remove the lines because that will make this a bit messy. And then I can just try my best to make a nice circles and then go from there. But since this is how we actually do with the paper and pencil, and I will just leave that for you to try by the way, but I'm gonna show you a bit nicer picture than this. Okay, so if I draw this, okay, so we should have something like this. I just did this on GeoGebra. So if I do them, this is not even like scale either. I just rough like draw, and then that will be my intersection. If I really did the segments like based on the given values, maybe I can have better like picture or maybe accurate picture. But this is something we are gonna get. This is kind of similar to what I have when I did manually. Okay. But this is not really helpful either, as I mentioned, because we have too much involved there. So what I'm gonna do, I'm gonna remove the lines, and then if I need to add them, I will do as we go, okay? So let's say after we remove those bisectors and the medians, this is what we have, right? And what I will try is the ratio. So let's actually understand the question. When you have this point as intersection, right? Because they are telling us there's another point P other than A. When you have those two circles and they intersect, which is this point, and then connect that A to P, that segment will intersect BC at Q. That's the point Q. And based on this ratio of BQ and QC is what we are looking at. So it's already a challenge, right? So we are gonna have a lot of work because this is number 15. So what we have now, we know based on the previous like picture. So we had this is 7.5 because this is N, and then this is A to M 6.5 because that was also midpoint. But we don't know the each pieces yet. So, and then what we want is the ratio. So when you see the ratio, there are a couple of things we can do. We can use the area approach, like to find the area of ABQ divided by AQC to find the ratio of the bases. That's one thing we usually use. And maybe second, we can try find some similar triangles and stuff that will give us some ratios as well. But we'll see which one or something else will be useful to get that ratio. But at the end, we are looking for the ratio. So since we are like given the N and E angle bisectors and medians, right? Median and angle bisectors from this point C, maybe that's this distance really important. So let's go ahead and use our angle bisector. So if I want to find the angle like side and E by using angle bisector, if you remember this is 7.5, so NA is also 7.5. But if I connect the E, which maybe I should draw a bit kind of to see how that looks like, but it's gonna make it a bit obvious. So let's say this is my triangle, right? So if I try the NE, so I will say this is one of these, and this is the second one. So this is A, B, and E, and this is C. So like we know this is 13, and this is 14. So the NB was 7.5. I made this a bit smaller so I can kind of see it. And we are interested, you know, the ratio, like we know that E and like EC is the angle bisector. So this angle and this angle are equal. So ratio of 13 to 14 is gonna be this ratio 13K to 14K. So if I know the AE and I can subtract AE from NA to get the NE, which is like 7.5, which is 15 over 2, minus and I'll just need to know this guy. But this is also like, you know, the ratio of the whole thing was like 13 and 14. If you add them, that's 27, right? So this is 13 out of 27. So 13 over 27 times the AB, which is 15. And I can cancel this. That should be 9. That should be 5, 65. So 15 over 2 minus 1, like 65 over 9. If you simplify for this, we'll get an E as 5 over 18. So I'm going to remove this part. So I'm going to just leave the final answer. So that's 5 over 18. So make sure you really get this on your own as well. If you use the same logic with the other ones, if you connect B to M and B to D and then use the similar reasoning, so we are going to able to get MD same way. I don't want to draw the second picture again, but if you do really the same thing as the other, like angle bisector and the median, so you will get 13 over 58 for the MD. So this portion. Okay, this is already a lot of work, right? But now, since we know these points are given and then somehow they are important, so maybe we may connect these guys to get some stuff, because we are given some similar, like like circles, so we may have some similar triangles. So which we are gonna go for. And if I connect these, we are gonna able to see if there are some angles also, right? So what we know that, like, if you look at the circles carefully, so the one of the circles that we have is this guy, right? The yellow one. But if you look at the yellow circle, so we have like the A, right? And like P and M. So if you look at that like quadrilateral A N P N, so maybe I should write that. So the A N P M. So if you look at this quadrilateral, we do see that the angle right here, like this is straight line, AN is straight line, and then NP is a straight line, and PM and PA. So meaning that the angle right here, maybe I should use different color. So the angle right here, and the angle at M are add up to 180 degrees, because the AD, like ANPM, is cyclic quadrilateral. So opposite angles are add up to 180, which will make this part is the same as this angle. So again, if that's not really clear, so just our cyclic quadrilateral, so which is why we do have that relation, right? And now we have these two angles are equal, so we can maybe hope for another one similar to this relation. So let's look at the other triangle, I mean others quadrilateral. So A, like we have AE PD. So if I look at that one, so the AE like PD. So like is cyclic, right? And then this is also. So the angle right here inside, like if you don't really see, you can make that quite a bit visual, so it may be colorful. So the angle right here, this angle E and the angle at D are complementary, I mean supplementary. So this angle and this angle are supplementary. So then if I take the supplementary of this angle, so this angle right here and this angle right here, D has to be same, because they both supplementing the angle right here, so AEP. Okay, so based on this, we do have this triangle and this triangle have two same angles, so that means they are similar. So maybe we can draw those two triangles as well, just to visually really see it. So let me do that. So we have this one. Okay, so like this is N. This is E, and this is P, and this is M, D, and P. So like N is right here. So let's keep the color the same. So the N is the same as M, so which is right there. These are equal. And now we have the purple angles, which is the angle E. Okay. So this angle and then angle D. So make sure you convince these like yourself before you move on. So that means these two triangles are similar. So let's write the ratio. I'm kind of scared writing some like background, like writing similarity statements and stuff. So let's continue. So if I take the NP, right, that's my, I mean, like the side NA, because we know the N, like NE actually. So NE is given, so we know the NE over, that's the side, and then this is angle opposite, so that angle is opposite MD. So we are gonna divide this by MD because they were similar. This is equal to, I'm gonna take the NP because we know this angle. So the NP, and the same angle is right here, opposite PM. So this is equal, right? And we know that NE was 5/18 and D was 13/58. So that means this fraction or this fraction is equal to like 5/18 times 58/13. If you simplify by, I guess, 2, so you will get 145/117. Okay, so this is already a lot of work, right? But still, it's not too bad so far, I guess. So we know that NE divided by MD or NP divided by PM is given as this number. So why do we care about this? Because as you see next step, we're going to try finding the ratio of BQ and QC by using the sum ratio of the sides. But we know this side, we know this side, we know the whole thing, but we don't know the fractional part, right? So what I'm going to try now, since we have a lot of angles going on right here, so maybe we can use some law sign. So let me try right here. So if I use the triangle, right? So the A and P, so the A and P. So the triangle A and P. So this is the triangle A and P. If I write the law of sine based on that triangle, so the NP, I'm gonna take as my first side because that is one of the sides that I have some information, divided by the sine value of the opposite angle. So NP is opposite the angle A, which is BAQ. That's what we are really interested. So the angle BAQ is equal to the AP, like remember we are in A and P. So the next side I will take AP because that's AP is the common side in this triangle, and the one I will check on the other one, divided by the opposite angle to AP is this one. I'm gonna name this is like either N or alpha, whatever. So that will be sine, I'm gonna say alpha. So this is alpha. So I'm gonna say this is alpha because I know this is the same as well. Okay, so now if I take another triangle, which is gonna be AMP, and then take the law of sine by using A and P, this is M, this is P. So like I can start with PM, so which is gonna be PM over the sine value of the, like PM is this red segment, opposite angle is this one, which is what we are interested as one of the angles as well. So the QAC. This is equal to, since we know we pull the AP on the next other triangle, so I can take the AP again and AP over, so we know AP is opposite to in AMP. AMP is this angle, but this angle is not the same as alpha. That's 180 minus alpha. Sine 180 minus alpha, which doesn't matter because the sine value of two supplementary angles are equal. So this is same as this one. This is same as this one. That means this fraction same as this fraction, which will combine the left side of these proportions are also equal. And that will give us NP, right? So the NP over sine BAQ is equal to PM over sine QAC, because that was QAC. And what we know is NP, right? Over PM. So we already know NP over PM is this number. So which is why we are gonna like swap these guys. So then that will give us NP over PM, which is 145 over 117 is equal to sine BAQ. So sine value of BAQ over sine value of QAC, right? So QAC. Okay, so why this is really helpful? Because at the end of the day, we are going to find the ratio of BQ and QC. If you remember at the beginning, I mentioned the area relation between two triangles. So now we can take the area formula, which is like one of the formulas that we use for the area of the triangle is 1/2 times two sides and times the sine value of the angle in between those two sides. So this is one of the common formulas I use. So now if I take the area relation between ABQ, the area of the ABQ over AQC. So the reason I'm going to use because that's going to give us the ratio of a BQ and QC. So this area is actually the same as what we are looking. So that is going to be BQ over QC. So if I write this formula, I know the two sides like will be AB and AQ, and AQ will be in common in both triangles, which is going to actually help. And I will take 1/2 times AB, which is 15, and then AQ times, this is Q, times sine value of BAQ. So the sine value of BAQ. This is gonna give us the area of the triangle ABQ. And the denominator is 1/2 times the side AC is 13 times AQ, which is the common side, times sine value of the angle right here, QAC. And these guys are conveniently canceling each other, so that's also. And what we are going to left is for 15 times sine BAQ divided by 13 times sine QAC. But we already know that ratio right here, BAQ, sine BAQ divided by sine QAC is this fraction. So that will give us 15 times 145 over 13 times 117. And you can simplify as much as possible. If you do so, you will end up getting 725 over 507. And that is my final answer. But since this is AIME, we don't have the fractions, so we just need to find those difference between numerator and denominator. So if you do so, so that will be 218 as our final answer. So it was a bit involved. We used a lot of like geometry background and did some algebraic manipulation stuff. So I hope that was clear. Like as I mentioned at the beginning, I will add some of the stuff that I use in this solution as like kind of background. So if you don't really know some of these, so make sure you really dive into those and do more practice, and then come back to problem and try and see if you can really do this problem on your own, and that will give us much better understanding of the concept. Okay, so I'll see you in the next video.